welcome back to Maths with Mitch. Today we're going to be looking at more trig identities that you might use to help you solve some problems. So moving on from the fundamental trig identity that we looked at last time, I'm going to derive a couple more identities, and then you can watch in my next video how we're going to use them to solve things. So let's start with the fundamental identity that we looked at last time. We have cos squared theta plus sine squared theta equals 1. Now this might be useful in certain situations when you're solving some things, but sometimes we need it in different forms that are going to be a lot easier for you to see when you're evaluating problems. So the first thing we can look at is if we consider dividing through by cos squared theta, remembering that we do the same to both sides. The cos terms will cancel out, so we'll be left with 1 plus sine squared theta over cos squared theta, remembering that sine over cos is tan, so if we were to do the square of those functions, we'll end up with tan squared. I can spell tan correctly. Tan squared theta equals, and then on this side we have 1 divided by cos squared theta, so we have the reciprocal of cos, which is sec, so we have sec squared theta. So that is our first identity that we're going to be using in addition to the fundamental. And let's now look at our second identity. So again, we're going to start with the fundamental. So always use this as a start point if you forget. Cos squared theta plus sine squared theta equals 1. Now this time, rather than divided by cos squared theta, let's divide by sine squared theta. That would make sense also. So let's do the same thing. Divide through by sine squared theta on both sides. This time we have cos over sine. Now last time we said sine over cos is tan. So the opposite way around, we're going to end up with a reciprocal 1 over tan. Remembering that the reciprocal, so 1 over tan, we could also write as cot. So this time we're going to be left with cot squared theta plus sine squared theta divided by sine squared theta, we're left with 1. And this time we have the reciprocal of sine. So the reciprocal of sine is cosec. So we're going to have cosec squared theta. So that is where we get that third identity. Now it might be the case that in your exams you're presented with a formula booklet that has the fundamental and these two in there, and then you're going to be able to use them, but this is a useful exercise just so you can see where they've come from with the fundamental identity.